All right, this video is going to be about a linear regression confidence interval for slope. So do absences affect your grade? A certain college professor believed that absences don't impact final grades in her intro stats course. From her 5 sections of intro stats from last semester, 130 students, she takes a random sample of 10 students and records the number of absences and final grade. We have the table of the data. We have the scatter plot. This is your residual plot, a dot plot of your residuals, and then here's a regression output. So remember that in the regression output, this gives us our slope, B. The 87.61 is our y-intercept, A. The 0.3 is the standard error of our slope. And then this is a t-score, or a test statistic, and the p-value. And we'll get to that when we talk about doing a test. So the first thing I need to do is choose the procedure. It says construct a 95% confidence interval. So we are doing a t-interval for slope, B. Okay. Beta is a population slope, so we're going to use beta. And it says the interval for the true slope of the population regression line for the number of days absent and final grade. That's our parameter. Beta equals the true slope of the population regression line for the number of days absent X and Y final grade. It can never hurt to just copy it from the problem, okay? So we have 95% confidence. The statistic is lowercase b equals -1.58. Now our regression equation would be y hat equals 87.61 minus 1.58x, or final grade hat equals 87.61 minus 1.58 times number of absences. So we check our conditions. Okay, that was choose, this is check. We check liner. The first L stands for linear. Does the scatter plot look like it has a linear pattern? So yes, scatter plot. And you need to write this down. You can't just put linear check or L check. You have to write scatter plot has linear pattern. And does the residual plot show no pattern? Obviously, I'm in my classroom. I is independent. Each student's absences and grade is independent of each other. So each student is independent of others in the class. Normal, CN. We look at the dot plot of the residuals. So the dot plot shows no strong skew or outliers. E stands for equal standard deviation. The residual plot is equally spread. No Christmas tree pattern. And the last is random. It was a random sample. So all the conditions are met, so we can continue. R calculate. We're doing an interval, so point estimate plus or minus margin of error. So the specific formula is B plus or minus T star times the standard error of B. Now remember, we pointed to B. So our B and our standard error, the only thing we need is the T star from the table. And the degrees of freedom is n minus 2. So we have how many? We have 10 students, so our degrees of freedom is 8. I want 95% confident. So we have, let's see, it's going to start with negative 1.58 plus or minus T star, we're going to look that up in a second, 0.3. Okay, that's the standard error, that's the slope. And let's look over at our table here. I just imported a picture. I have 95% confident and 8 degrees of freedom, so 2.306. 2.306. And then we'll do the math. So we get negative 2.2718 and negative 0.882. Now both of the intervals are negative, so there is evidence of a negative association. If zero's in the interval, there's evidence of no association. And then our conclude, we are 95% confident the interval from negative 2.27 to negative 0.88 captures the true slope of the, we can abbreviate LS, least squares regression line, LSRL, for number of absences and final grade. And then if you're asked, like I said, if there's evidence, yes, there's evidence that there's a negative association between number of absences and final grade because both of our interval numbers are negative. If it goes negative to positive, then there's evidence that there's no association. And if there's both positive, then there's evidence of a positive association.